Hi, I'm Brianna Manwaring.
I'm Ashley Paulson.
I'm Michael Larole. Okay. Are we just going to start with question 1?
That's good for me.
Cool.
So for 1A, I got that you're going to have one homozygous dominant, 2 heterozygous, 1 homozygous recessive, but because the father or male genes are basically depleted, or I can't remember the correct term, but you only see the female alleles, and they are I got half dominant and half recessive.
Okay.
Perfect. For B, what I did is I did the Punnett squares, and I ended up getting that the genotype was 50-50, and that they were all going to be recessive and have the syndrome.
Okay. For number C, letter C, I did found that they had 0. There will be 0 of the X of bar bodies. I mean, 0 bar bodies, and that's because if the XICs have been deleted, then it won't be able to make then none of the X chromosomes will be turned into bar bodies.
For D, I got that there would be 2 bar bodies, seeing as the 26 genes on each chromosome are non-functional, but the X, I probably said the wrong genes on each chromosome are functional. It will form the 2 bar bodies.
Perfect. That's what I got too. Okay, for 2A, I got it's the SRY. That's the example of the Holzrak gene.
For B, I got it'll be MIC2. Is what it is.
For C, I got that half of the offspring will be normal and half will be dwarfed because the female alleles are silent.
Perfect. And then for D, I said it was in the sex pattern of inheritance that the allele dominant will be dominant for one sex.
And for E, I got genomic imprinting and then dosage compensation. That sounds right, you guys.
Sounds good. For F, I got X, IST, and T6.
Perfect. Okay, so moving on to 3.
But we still have G.
You are, oh, G, sorry, yeah. So I got it's located on the autosomal, and then for the next part, it is the sex chromosomes.
Okay. Number 3, it said, what is the genotype of the woman's father? What is the genotype of the woman's mother? So for the dad, I put he would be X but recessive, and then the female would be homozygous dominant.
For B, I put because there's after that, so I put the son would only have 25% chance of being affected.
Perfect. For C, when it's talking about the genotype of the male, so it's going to be X with a little b, and Y because he's an infected male. So.
Okay, for D, for the genotype, it would be for the first female would be heterozygous, the second female would be homozygous recessive, then the male would be one dominant and one recessive.
And then for number 4, so suppose that a cross produces a 3-beard, 1 no-beard phenotype ratio among female offspring. And I got for the phenotypes that you have big B, little b for both of them, so they're both heterozygous. The male has a beard and the female has no beard.
Perfect. Okay, so for B, it's going to be big B, little b for the mom, and big B, little b for the dad as well, with the 1-to-3 ratio.
Okay, you see, they have it'll be heterozygous dominant for the male, big B's, and then heterozygous for the female.
Kind of gross. We're on D, right?
Yeah, 40.
I put the female would be little b, and the male would be big B, little b.
Perfect. Okay, so 5A. So the genotypes and the phenotypes. Okay, so you're going to have 1 orange, 1 black, or the orange is going to be female. You're going to have a black and an orange male, and then a tortoise female. And then for the genotypes, it's going to be X, big B, little b, 2 little b's, BY, and then big B, Y.
For B, I would got that what it would have to do is kind of mix up these X, X, Y with heterozygous. And so X, big B, X, little b, and then Y.
For C, I got big X, and then X, B, Y, little by, and then I put 2. And you get 2 female carriers and 2 male ones.
Perfect. And then for D, I said it's going to be 2 little R's with 2 big R's. The 2 little R's are going to be the male, and the 2 big R's are going to be the female. And there's going to be 2 big R males with 2 little R females, and none are going to have it. So that's what I said.
Okay.
Perfect. See you guys next week.
See you next week.
Bye.